Pulse width modulation is a type of signal which can be produced from a digital IC such as microcontroller or 555 timer. In our case, pulse width modulation is controlling the duty cycle of the pulse train output of timer 555. But what is the duty cycle? First you must to know the on time and off time. On time is the signal high voltage of square wave as you see. Off timer is the signal low voltage of square wave as you see. Now you can understand duty cycle. It is the percentage of time in which the PWM signal remains high on time, is called as duty cycle. So duty cycle equals turn on time / turn on time plus turn off time. As you see, the following image represents a PWM signal with 50% duty cycle. As you can see, considering an entire time period, on time plus off time, the PWM signal stays on only for 50% of the time period. After understanding the duty cycle, now the pulse width modulation is controlling the duty cycle. As you see in this photo, this pulses is modulated. And this is the expected output we must see on oscilloscope. The duty cycle and frequency of a PWM signals are often confused upon. So we put two oscilloscope videos that show the difference between them. Connections. First, add timer 555 IC. Now we will connect VCC pin 8 and reset pin 4 to positive voltage. And ground pin 1 to ground. Connect the two capacitors long terminals to pin 5 and pin 6. And short terminals to ground. After that we will connect pin 7 to positive voltage through 1 kilo ohm resistor. Now we will connect potentiometer metal pin to threshold pin 6 and trigger pin 2. After that we connect the two diode as you see in circuit. Connect your 12-volt DC power supply. The output pulses will be on pin 3. We will measure it using our oscilloscope. Let's try. As you see on oscilloscope, we can control the duty cycle. So the circuit is working.